All right, hi guys. Here we are, week 2 of this fun lessons at home. Hopefully you guys got through last week's lesson and it was okay. And I'm excited to have your parents email me the picture of what you guys, how you guys followed along, your papers that you worked on and wrote on while we were having a class. So again, today be ready with your paper. I want you to have 2 pieces of paper if that's okay. I would love it if one of them could be like a white, just computer paper. If not, that's okay. Just get your piece of paper and be ready with a pencil and let's begin. Okay, 2 things from last week's lesson. Go ahead and write something down that you remember. Whatever comes to mind, write down what our lesson was. 2 things. A hint. If nothing's coming to you, remember you can always pause me if you don't want to hear a hint. Pause me. Come up with something on your own, or just more time to think. But we learned about 3 words. 2 of them start with R. 1 of them starts with a D. There's your hints. All right. So go ahead, write something down on one of your pieces of paper. On one of those pieces of paper, do leave it blank because we're going to do a little project on this. So if you started writing on one, that's the one you're going to do your writing on. The other one we're going to do writing, but it's going to be different, more of an assignment. So, okay. All right, we're going to jump in today. So a few weeks ago, we had a lesson on heat and temperature and the difference between the 2. So I would love it if I could have you guys raise your hands and tell me the difference between temperature and heat. But obviously we can't. So if you guys remember, pause me and write it down. If you don't remember the difference, I'm gonna get into that. So if we remember correctly, heat refers to the energy in the molecule. So remember, heat is the one that's going crazy with all of the energy, and then temperature comes along, and temperature is the measurement of that energy. So remember back, heat is the energy, all the little molecules that are going crazy, and the hotter it is, the crazier they go, and the colder it is, the slower that they move. And yes, I talk with my hands, you guys know that, sorry. But then we have temperature that is going to come and measure that. It's going to measure that, and that's how you're going to get your temperature. So we're not having that lesson again. I just wanted to refresh on that, because remembering that, we are going to continue our study about heat and energy and heat transfer this time by learning about conductors and insulators. So with that, I'm going to give a good little review video here, and it can kind of, see where is it? It will just give us a little recap on what conductors and insulators are. All right, here we go. Maybe go big. There we go. To the beginning and play. The only material that conducts energy? What do you think? Nope. Water can conduct electric energy as well. What is an insulator? Material that does not easily allow energy to flow. Can you think of some examples in your head? Wood and fabric. Wood is a good example of a thermal insulator and just a little recap. Gotta make sure it stops. The other, it's not stopping. Hopefully you can't still hear that music, can you? Let's see. Okay, now I lost my screen. Where'd I go? Oh goodness. Oh, there I am, I'm back. Okay, sorry. Sorry, it just gets a little crazy trying to figure this out when sharing screens, and I'm gone again. There I am. All right. Okay, sorry guys. I said this time would be smoother. It's getting smoother, right? It's getting smoother. Okay, so there's our little recap. On your paper now, I want you to go ahead and fold the blank paper, nothing that you've written on yet. I want you to go ahead and fold it in half. So just like this, fold it in half, and then I want you to go ahead and write conductors and insulators on your paper. Put a line underneath it, but I want conductors on one side, insulators on the other. If you want to fold it this way, that's fine. I just did mine that way. So conductors and insulators. And I can go ahead and spell conductors for you. C-O-N-D-U-C-T-O-R-S. And then insulators, I-N-S-U-L-A-T-O-R-S. So conductors on one side, insulators on the other. All right, let's start with conductors. So to conduct means to act as a middle to transmit something. So it acts as something in the middle to transmit something, either way, right? So when we add the OR to make conductor, did I say that right? Yeah, so to conduct means to act as a middle to transmit something. And when we add OR, so it's conductor, it means a material or object that conducts heat, electricity, light, or sound. So it would be a material or an object that conducts heat, electricity, light, or sound. So in a simpler form, I want you to write this down, the simpler form. A conductor, so under conductor, helps pass energy. So anytime we have energy, remember energy is molecules, right? Especially when we're talking about heat. Well, molecules are everything, but right now we are talking about heat and energy and all of that. So if we have a conductor, it helps pass energy. So we have energy that is going crazy. It's a molecule, and it's going to pass that. It's going to help that get moving. That is a conductor. Okay, so on your paper, you should have conductor on this one, and then I want you to have helps pass energy. That's your hint. Okay, that is your simplest form of a definition. Get my notes here. Okay, now what are some examples of conductors? So everyone pause me, and I want you to write down as many as you can. Some ideas. What is a conductor? So right here you have helps pass energy, and then all on the rest of this side, anything that is a conductor, anything that's a conductor. So take a few minutes, pause me if you need to. Just keep writing down all of your ideas that you can. And I'm gonna start naming a few that I came up with. And I wish we could all share what we all came up with. We will. I get to see what you guys came up with, because at the end of this, I want a screenshot of your piece of paper emailed to me. So I came up with paperclip, an iron, scissors, penny, all sorts of metal. What else? Did I say paperclip? Yes, paperclip. So those are some that I came up with. Hope you guys have some different ones, some super creative ones. All right, so that is a conductor, helps pass energy. So now we are going to move on to insulators. This is the other side of our paper. What is an insulator? I want you to turn to your sibling or parent, whoever is near you, and I want you to tell them what you think an insulator is. Anything. It could be anything. So go ahead, take a second to do that. All right, come back to your paper. So let's talk about what an insulator is. So an insulator is a material or an object that does not easily allow heat, electricity, light, or sound to pass through it. So it's something, material or an object, that does not easily let anything pass through it. Anything. So those little heat molecules are going to have a really hard time getting through that. So in simpler form, for an isolator, it helps stop the passing of energy. So on your paper, I want you to put, let's get mine up. Oh, it's so backwards, I forget. Helps stop the passing of energy. So conductors help it, insulators stop it. So again, that one more time, help stop the passing of energy. All right, here we go again. I want some more examples. Be super creative. Lots of examples as to what an insulator is. I want you to write all of those down that come to mind. I don't know if you can see, I don't want to show you the other half, but my insulators, I just wrote tons of ideas down here. I want your ideas on insulators. Lots of ideas. Pause me or take a few minutes and do that. All right. I know I'm not giving you guys enough time, so hopefully you guys are pausing me and coming up with lots and lots of ideas. Okay, how do we connect conductors and insulators to heat energy or heat transfer? Like I said, we're coming back to our heat that we learned about a couple weeks ago. So heat energy or heat transfer occurs when temperatures of objects are not equal to each other. So today's experiment, we are going to find out what materials act as a better insulator or conductor of heat for the heat transfer or the heat energy. Okay, so again, we are going to find out what materials act as a better insulator or conductor of heat. So that is our objective for today. All right. Okay, so we'll get onto the project or to the experiment in just a second, but I want you guys all to imagine it's a freezing cold winter day, but it's sunny. So there, you know, like when there's no clouds and it's really cold, it's one of those days. So cold winter, but sunny day. It's freezing outside. And you decide with your friends or your family, whatever, you're gonna go on a winter hike up into the hills. So you guys want to take some hot chocolate. But what's going to happen if you go outside in the frigid, cold winter air and you have hot chocolate? Well, lots of different things could happen and some things could not happen, right? So you go to the cupboard, you get a mug. Do you guys like this giant mug? So you get a ceramic mug. You're like, I wonder if that would work. Or you get a metal mug. This is metal. You get a metal mug or you get a thermos. What would you guys choose to put your hot chocolate in to go outside on a hike in a frigid day? What would you choose? I'm thinking y'all are gonna answer this. Write it down on not this piece of paper, but your other piece of paper. Go ahead and write down what you guys think. If it's the ceramic mug, okay, the metal mug, or a thermos. What do you guys think? Write it down on your other piece of paper that you're just writing on. So, all right, we're gonna go over that a little later, the answer on that. But this brings us to our project for today, our experiment for today. And we've got to kind of flip a few things because in class I would have all of these different kind of materials and thermometers and stuff, so we would be able to do this in class a little differently, but you're at homes, so we're gonna get creative and it might actually be easier. So hopefully you all have some hot chocolate or apple cider, something that you can warm up that you can add water to. It needs to be able to boil water to add to the powder of whatever it is. So you'll need that for this experiment. But for this experiment, I'm going to have you guys design a thermos. And for those kids that I have siblings in my class that, anyway, there's multiples of you in my class that are siblings, you guys can work on this together. That's totally great. You guys can do this together, but make sure teamwork, everyone has a good idea, remember? So you're going to design a thermos at home with household items. And remember your thermos has to have a lid. I'm going to give you a few, like some ideas that you could use from materials at home, but if there's something else, I'm totally use it, like whatever you think. So some that I came up with would be styrofoam cup, paper plates, napkins, tin foil, packing peanuts, maybe you have some, grocery bags, wool socks, craft foam, rubber bands, fabric, empty ketchup bottle, empty mayo bottle. Just make sure you rinse it out first. Okay, what I want you to do for this experiment is go ahead and take notes on your piece of paper, your scratch piece of paper. I want you to pick 3 to 5 items in your home that you could use to make this thermos. On this other piece of paper, before you even begin, you're gonna pick 3 to 5 materials that either I named off, and if I went too fast, just go ahead and rewind me back a little bit, and if you can't think of some materials at home. So you're gonna write down your items that you chose to use, 3 to 5, and then you are going to design it on this piece of paper. Very first, before we even get started, we have to do our plan of action, right? So very first, you're gonna write down your materials that you chose to use. I wanna know what ones you decided to use. 3 to 5 materials from your home. Then make sure you make a lid for this thermos. So once you get this thermos created, then you gotta try it out, right? So back to our paper, we've created it, we've picked our materials, we've created it, and now next we're gonna say what's gonna happen. And in that, it's either gonna hold its heat, it's gonna lose its heat, and I want you to write that down. I want you to write what your design is going to do. Then you can make a different column on what actually happens. So you have your 3 to 5 materials, you have your design, you have your what you think is going to happen, and then you have your what happened. And this is how you're going to test what happened. You have your thermos, it's all made. You're gonna get whatever you can at home that you can boil some water and add to it. So if it's hot chocolate mix, great. Whatever you can add boiling water to will be awesome, it will work. So you're gonna make your hot chocolate in your designed thermos that has a lid. You're gonna put it in and it's going to start out with boiling water. Then you're gonna cover it. And I don't know if some of your parents will allow you, if you want to do this part, this would be great. If you can't do this part, it's totally fine. Most of this experiment was to figure out how to have an insulated thermos, right? That's what we're trying to aim for here. Hopefully I didn't give too much away there. So once you have your hot chocolate all mixed in, if you do have a thermometer or a food temperature thing or some way to take temperature of this hot chocolate, you're gonna you're gonna set a timer for 20 minutes. You're gonna start with the temperature, you're gonna do 10 minutes in, and then you're gonna do it at the 20-minute mark. And you're gonna see the difference of those temperatures. And that is how you will know if you created a highly effective insulated thermos. So that is our goal in this experiment. If you cannot take temperature, that's okay. That is just fine. Use your finger. You can totally use your finger to be like, okay, it's not as hot as it was when it was boiling, and it's not as hot as it, or maybe it's cold by that 20 minutes. So that's a good gauge too. totally whichever direction you want to go, but whichever direction you go, I want to know if you did the finger thermometer or if you used a real thermometer and what those temperatures were. So it's kind of a fun little project experiment at home, and I want to know all about it. So make sure you get a picture of this paper and then a picture of your designing thermos paper worksheet with your materials. I'm excited to see what kind of materials you guys are gonna come up with. Work as a team, siblings, and send me those pictures in. That's our lesson for today. And at the bottom of your paper, write 2 things that you learned about from today's lesson. All right, good job, guys. I'm excited to see all of this, and we will see you next week.